All right. Hey, good evening or good morning, whichever it is you happen to be looking at it. We're going to be looking at a sine graph. And the way we're going to do it today is we're going to actually plot some points using actual numerical values. And the first thing we're going to look at is this. Look at quadrant 1. And I'm going to look at 0 degrees, 0.5, 15 degrees, 30 degrees, 45, 60, 70, 89.5, and 90, as you can see. And in radians, I'm going to convert these to radians. And the x's mean you don't have to, for these particular ones here. There's a reason the 0.5 is there. It's not really for the sine degree, but for one coming up later. But notice this. 0 degrees is 0 radians. 15 degrees is pi over 12. 30 degrees is pi over 6. 45 is pi over 4. Pi over 3. You can see 5 pi over 12, and 90 is pi over 2. Okay. Now the whole reason for this is the following. I need to use those. I'm going to convert radians to decimals to make the graphing a little easier. And if I was to convert pi, take 3.14 and divide it by 12, I get 0.26. 3.14 divided by 6, I get 0.52. Pi over 4 divided by 4 makes 0.79. In other words, this is the radian in decimals, and this is the radian with the pi in it. Now, I'm just kind of using that to help me for my graphing, to help understand some things. And notice this. What is sine at 0 degrees? Well, if you go to your chart or your unit circle or your calculator, you'll find it's at 0. You will also find that it's sine at 30 degrees. Remember the Sheldon-Cooper part from the Big Bang Theory? It's exactly 1/2. And sine at 45 is square root of 2 over 2. And the square root of 60 degrees, sine at 60 is square root of 3 over 2. And sine at 90 degrees is 1. And if I convert these to decimals or use the calculators, I get this. Now this is going to be important because I'm going to use these numbers to actually graph some points. I don't know that I'm going to use particularly these, but I'm going to use at least these right here, the big ones that we see a lot on our sine graph. And notice we have a point at 0, 0. And then at pi over 6, which we said was around 0.5 something, it's exactly 1/2. And if this is 3.142, 0.5 is about right there. The next value, square root of 2 over 2, is around 0.7071, is exactly at like pi over 4, which is exactly on this line right here. 60 degrees is 0.866 in decimal, which is a little bit bigger than 1. I think it's close to that one as a radian. And then as we also look over here at this next number right there at pi over 2, or 1.57, it is exactly 1. Notice my sine graph starts here and it goes up like this. Nice little pattern. Let's remember something about sine. Do any of the values ever get larger than 1? No, because the hypotenuse is always the biggest side. So when you divide by the bigger thing, it's always going to make a smaller one. So let's look at quadrant 2 and see what happens. Notice there are the radian numbers right there for the degrees. There are the radians in decimals, if you wanted to convert these to a decimal to see it the graphing. And the exact values would be the following. Well, 120, it's square root of 3 over 2. At 135, that's an alpha angle of 45, which is square root of 2 over 2. And 150 is an alpha angle of 30. But your sine is positive all in quadrant 2. And those would be the decimal answers. Oh, wait a minute. Weren't those the exact same decimals we had before? Well, they were small going up. Now they're bigger going down. So if I was to graph them, they're going to look like that. Made kind of a parabola right there for quadrant 1 and then quadrant 2 on those values. Okay? It went up, and these are the same equivalent spots going up because the values were the same. If you look at your unit circle, as they go up, they're coming back down. What do you think is going to happen over here? Think it's going to go back up, or will it continue to go down? That's a great thought question. Let's find the answer to that. Well, what happens over here? Well, here's our degrees and here's our numbers in radians. If I make the radians in decimals to kind of help with graphing. And look at the exact values. What is sine at 210? Well, it's the alpha angle for 30 degrees. Well, at 30 degrees, sine is 1/2, but in quadrant 3, it's going to be negative. Hence, then all the numbers will be negative, and 45, the 225 is a 45 degree one, and 240 is a 60 degree, but the answers are now negative. And notice at the 270, it's at -1. Or if I want to convert those to decimals to make it easier to graphing, because I understand -1/2 is -0.5, and these values here. So as I go to graph them, notice I have the same number of dots going up right there. Now these values are going to do the same, but going what? They're going to go down. Ooh. All right. So what do you think is going to happen to the next part? They went up, down, they kept going down negative. And remember, it can't be lower than -1 because the value of the hypotenuse has to be the bigger side. So obviously it has to go back up. And if we look at our numbers, here's the numbers in radians. Radians is decimals if you want to use a chart, different type of chart to graph. In exact, notice the values are negative, but they're going to be getting closer to 0. And you can see the numbers were exactly the same as the other side, just flipped. They are now negative. I mean, that 0.807 was way over here, but the numbers are going like that. So when you go to graph it, notice it's going to make a graph like that. Well, theirs is from 0 to 2 pi. But what do you think is going to happen if I go to the negative side? Well, notice, do you think it's going to go back up like that? Or will it continue to go down and around like that? Well, the best way to do it is to go plot some points, but you really only got to go plot one. If I did the sine of -30 degrees, well, think about it. -30, negative pi over 6, that's in quadrant 4. And what is sine in quadrant 4? It's going to look exactly like that one. And so then the graph's going to look, this side went like this, and the other side's going to be just a continuation smooth. The sine graph makes a wave. And the big key of the sine graph is this. It starts at the origin, 0, 0, goes up to 1, back to 0 to 1, -1, 0. But it starts at 0. Sine graphs start at the origin. All right? For those that might want to think, oh, I guess I'll, sine less close to sin. And where did that first start? When people were first here. All right? So there we go. Sin goes all the way back to the origin. There we go. Sine and sin. Sine, origin. There we go. That'll help you remember.